Imagine a weapon designed to change the face of war. An unmanned tracked vehicle steered by a joystick, rolling silently across the battlefield with 60 kilograms of explosives. Nazi Germany built over 7,500 of these so-called genius suicide drones, promising to destroy tanks and bunkers without risking a single soldier. But on the front lines, that revolution stopped cold. Cables were cut by teenagers, armor shattered under basic gunfire, and most units never reached their targets. Why did a marvel of engineering become a byword for costly failure? And how did this forgotten disaster become the unlikely ancestor of today's lethal kamikaze drones? To answer that, we need to dissect exactly how the system was supposed to work and why it was doomed from the start. A Goliath operator waited in a shallow trench, clutching a metal control box connected by a thick triple-strand cable stretching out across the battlefield. The system was simple in theory. 2 wires inside the 650-meter cable steered the left and right tracks, while a third wire triggered the detonation. With a push of the joystick, the operator could guide the 1.5-meter long vehicle forward, aiming its 60 kilograms of explosives toward enemy barricades, tanks, or bunkers. But there were no cameras, no sensors, just a direct line of sight. If the Goliath crested a rise or vanished behind rubble, the operator lost all control. This cable was both the Goliath's lifeline and its greatest vulnerability. Every meter of its advance left a visible trail, the cable snaking behind through mud, debris, and shell craters. In August 1944, during the Warsaw Uprising, Polish resistance fighters, many of them teenagers from the Gray ranks, learned to spot that cable. As the remote-controlled mines rumbled toward their barricades, these young fighters sprinted into no man's land, knives and shovels in hand, risking everything to sever the connection before the explosives could reach their target. A single cut left the Goliath dead in its tracks, a silent heap of steel on the street. On the beaches of Normandy 2 months earlier, the cable's weakness played out on a different scale. German engineers had hidden Goliaths in camouflaged bunkers, ready to roll out and attack the Allied landings. But the opening naval bombardment, unleashed by British and American warships, was relentless. Exploding shells ripped open trenches and tore through the sand, shredding the Goliath's cables before the vehicles could even emerge. Most of the remote-controlled mines never moved at all. Operators, watching helplessly from their bunkers, found the control boxes unresponsive, disconnected from the very machines they were meant to steer. The idea of a remote-controlled weapon promised safety for its operator, but the reality was a fragile link exposed to every danger of the battlefield. The cable that allowed the Goliath to be guided from a safe distance also made it an easy target for anyone determined enough or desperate enough to stop it. At first glance, the Goliath's compact frame and remote control system suggested a weapon from the future, but its technical shortcomings ran deeper than a vulnerable cable. The vehicle's top speed, just 10 kilometers per hour, or about the pace of a slow jog, made it easy prey for anyone with a rifle, or even a well-thrown grenade. On open ground, defenders had minutes to spot the Goliath crawling forward and react at their leisure. Terrain posed another obstacle. With only 11.4 centimeters of ground clearance, the Goliath struggled over even modest rocks or debris. A single shell crater or tree branch could trap it, leaving the vehicle stranded and useless. Its payload still intact but out of reach of any target. The promise of remote destruction faded quickly when the machine could be stopped by a patch of rough ground. Cost compounded the problem. The early electric-powered model, the SDKFZ 302, demanded 3,000 Reichsmarks per unit. The later gasoline-powered SDKFZ at 303 brought costs down to about 1,000 Reichsmarks, but both versions remained single-use weapons. For comparison, a 75mm PaK-40 anti-tank gun cost 12,000 Reichsmarks and could be fired thousands of times. A dozen Goliaths, at the same price, would likely all be lost before reaching a single target. By 1994, Germany's war economy was stretched thin, and resources spent on disposable vehicles could not be justified by their results. Protection was minimal. The SDKFZ-302's armor measured just 5 millimeters thick, barely enough to stop small arms fire, while the 303 model offered 10 millimeters at the front, but left the sides and rear exposed. Heavy machine gun fire could penetrate from almost any angle, and a single armor-piercing round risked detonating the entire explosive charge prematurely, sometimes endangering German troops nearby. Even the control system was fragile. A German maintenance report described the joystick box as frustratingly fragile, with internal wiring easily damaged by moisture. In practice, the Goliath's engineering made it as vulnerable to rain and mud as to enemy fire. All these flaws, slowness, poor clearance, high cost, and thin armor, meant the Goliath arrived on the battlefield already at a disadvantage. The next test would come in combat, where theory met reality under fire. In July 1943, the rolling plains west of Kursk became the proving ground for every new weapon in the German arsenal. Soviet engineers had transformed the land into a maze of defenses, over 500,000 anti-tank mines, nearly as many anti-personnel mines, all buried in belts stretching hundreds of kilometers. For German planners, these minefields threatened to halt Operation Citadel before it even began. The solution arrived in the form of remote-controlled vehicles. The Goliath tracked mines and the much larger Borgward 4s. Both were assigned a single task: clear a path for the heavy Ferdinand and Elephant tank destroyers of the 654th Heavy Panzerjäger Battalion. The plan was methodical. Goliaths would lead, crawling forward to detonate mines and open lanes wide enough for the massive tank destroyers. Behind them, Borgwards, radio-controlled and carrying even larger charges, would follow, blasting deeper into the Soviet defenses. The theory was sound on paper. In practice, the Goliaths' slow advance made them easy targets for Soviet gunners. Their thin armor offered little protection from small arms or shrapnel, and the tangled ground of Kursk, littered with debris, shell holes, and barbed wire, stopped many Goliaths before they reached the first mine belt. As the attack unfolded, the limits of remote control became painfully clear. Operators, sometimes hundreds of meters behind the front, struggled to steer their vehicles through smoke and dust. The 650-meter control cables snagged on wreckage or snapped under fire. In the chaos, Goliaths detonated prematurely or failed to explode at all. The Borgwards managed to breach some obstacles, but the lanes they created were narrow and unpredictable. The cost was staggering. Of the 45 Ferdinand tank destroyers that advanced with the 654th Battalion, 37 were immobilized by mines before the first day ended. Crews abandoned their vehicles under artillery fire, forced to retreat on foot across ground their own machines had failed to clear. For the men inside those tanks, the promise of a technological breakthrough faded into frustration and loss. Kursk became the closest the Goliath ever came to justifying its existence, yet even here, in the largest armored clash in history, the machine could not deliver what its designers had hoped. The gap between ambition and reality was measured in burned-out hulls and shattered expectations. August 1944 brought the Allied landings in southern France, Operation Dragoon. In the rugged hills of the Maritime Alps, German engineers deployed the Goliath once again, hoping that the terrain and element of surprise might finally deliver the results their superiors demanded. The target: advancing American paratroopers from the 509th Parachute Infantry Battalion, men already known for their daring jump into North Africa 2 years earlier. As the Geronimos pressed forward, at least one Goliath managed to reach its mark, a vehicle in the battalion's column, detonating with the full force of its explosives. This single detonation stands as the only documented instance of a Goliath destroying an enemy vehicle anywhere on the Western Front. The larger context, though, is inescapable. By this point, nearly 7,600 Goliaths had rolled off German assembly lines. The program had absorbed thousands of tons of steel, copper, and fuel, resources desperately needed elsewhere, as the Reich's war machine sputtered. Each Goliath represented a gamble: 1,000 Reichsmarks for the gasoline-powered model, triple that for the early electric version. Yet for all this investment, the confirmed results amounted to a single Allied vehicle destroyed in the maritime Alps. The cost-to-kill ratio was staggering, unmatched by any other major weapon system of the war. Not even the most optimistic German after-action reports could disguise the reality. The Goliath's lone success was a statistical outlier, not a vindication of the concept. For the men of the 509th, the attack was a brief shock, a reminder that even a failed weapon could be deadly under the right circumstances. But for German commanders, the incident only underscored the gulf between technological promise and battlefield outcome. The Goliath had finally done what it was built to do, but only once, and only after thousands of failures. That solitary kill, achieved in the last year of the war, could not justify the enormous expense or the years of engineering effort. It stood as a final, sobering tally. One destroyed vehicle, 7,564 Goliaths, and a legacy defined not by triumph, but by the limits of ambition. Captured Goliaths did not inspire fear among the Allies. On Utah Beach, United States Navy sailors posed atop the empty hulls, grinning for photographs. American GIS treated the vehicles as little more than oversized toys. They stripped out the explosives squeezed inside and drove the Goliaths around like remote-controlled cars, laughing at the novelty. When the United States Army Air Force tried to repurpose Goliaths as aircraft tugs, the machines broke down almost immediately, unable to handle even the gentle demands of an airfield. The verdict from the front lines was blunt. This was not a weapon to be feared, but a curiosity to be played with or discarded. The Soviet response was even more clinical. In 1943, a captured Goliath arrived at the NIBT Proving Grounds for technical evaluation. The vehicle was missing its remote control, so Soviet engineers had to build their own just to get the machine moving. Their findings left little doubt about the Goliath's limitations. Battery life measured just 5 to 8 minutes, barely enough for a single run. Hitting a moving tank from even 100 meters away was described as nearly impossible. The hull, built from steel sheets only 1 to 2 millimeters thick, offered no protection at all. Soviet testers called it the German torpedo tankette, a name that captured its expendable nature and its lack of real armor or utility. The official Soviet report was unsparing. The Goliath, they concluded, could only be used for ambushes on narrow roads, and even then, at enormous cost. There was no attempt to copy the design or field anything similar in Soviet service. Instead, the Goliath became a textbook example of wasted effort, an engineering experiment that had failed every test of battlefield practicality. The reactions from both Allies and Soviets stripped away any lingering mystique. In the hands of the enemy, the Goliath was neither a terror weapon nor a technological marvel, but a failed experiment, remembered more for its shortcomings than for any threat it posed. By late 1944, even Germany's most determined engineers could no longer ignore the Goliath's failures. The answer, at least on paper, was a new vehicle, the Springer, officially designated SDKFZ-304. This machine abandoned the fragile cable and unreliable joystick in favor of a hybrid approach. Built on the sturdy NSU Kettenkrad motorcycle chassis, the Springer could carry 330 kilograms of explosives, more than triple the Goliath's payload. But the real innovation was the human operator. For the first time, a driver could steer the vehicle close to the target, bail out under cover, and then switch to remote control for the final run and detonation. The intention was to give the weapon a fighting chance against the chaos of combat, combining human adaptability with the expendability of a drone. Yet the Springer was a solution that arrived too late. Only about 50 were built before the war ended, a fraction of what the Goliath program had consumed. The Springer's heavier payload and improved mobility never saw widespread deployment. The war's closing months left no time for further experiments, and Germany's exhausted industry could not support another mass production gamble. The Springer's brief existence stands as a final attempt to salvage the core idea: an unmanned machine, risking itself so that soldiers would not have to. Today, the concept that began with Goliath's cable and ended with Springer's hybrid control has found new life in a very different form. On the battlefields of Ukraine, first-person view kamikaze drones, small, fast, and shockingly cheap, are launched by the thousands. Instead of 650 meters of vulnerable cable, these drones use radio links and live video feeds to hunt tanks and armored vehicles from miles away. The cost has dropped from thousands of Reichsmarks to a few $100s per drone. The principle, though, is unchanged: destroy something expensive with something expendable, and keep the operator out of harm's way. Hans Klein, one of the last engineers to work on the Springer project, later described the experience as a lesson in timing. "We built a machine for a war that was already lost," he wrote, but the idea itself was not lost. Surviving Goliaths and Springers now sit behind glass at museums like Bovington in England, the Warsaw Uprising Museum, and Utah Beach. They are reminders of a moment when ambition outpaced technology, and of how, decades later, the same logic would return to shape the future of warfare. Modern battlefields now swarm with drones built on the same disposable logic Goliath pioneered, only faster, cheaper, and devastatingly effective. As technology races ahead, the gap between ambition and consequence grows ever narrower. The lesson endures. Even failed inventions can rewrite the rules of war, sometimes decades later. In warfare, timing isn't just everything. It's the difference between history's footnote and tomorrow's front line. What do you think? Visionary or folly?